Today I'm going to be explaining my lab 1 to you. So the concepts used in lab 1 were the concept of charge, electric fields, electric force, superposition of forces, and gravitational force. What was the experiment? Essentially, I took a tape, stuck it on a table, and I put another tape on top of it, and just rip off the top tape. What that did was charge the top tape. I did this with another tape and brought the two tapes close to each other. They repelled. I did this with one tape and brought them close to various uh, objects around me. Most of them got retracted. Now, why does this happen? First of all, my expectations from the experiment. So when I thought that you bring the two tapes close to each other, that they should repel because they were formed in exactly the same manner, right? So they should have the same charge on them, and like charges repel. Now, why should the each U-tape have the same net charge? That's another assumption being answered from the PDF. That is because they got charged in the exact same manner and are of the exact same length. Essentially, they are subjected to the same physical conditions and therefore they should be identical in their charges. What was my observations from the experiment? I just told you all my observations. One thing to note is when I brought the tape close to the plastic pen, the thing got attracted, which essentially means that the tape was positively charged because unlike charges attract. What was my so I built a model for this. The red is the bottom tape and green is the top tape, which is sort of levitating in air. Why does this happen? This is because the downward force on the green tape is the gravitational force. However, there's an upward force, which is a repelling force from the red tape because they're of the like charges, and these two forces in the y component essentially cancel each other out, which leaves us with a non stationary green tape, which we call the levitating tape. The distance between the two tapes as seen by me was 1 centimeter or zero point zero 0.01 meters. Now from this, how can we calculate the charge? One is through the model and the other way is through equations, which is exactly what I've done here. So on the left is the equation for gravitational force, and on the right is the equation for electric force. On moving around the variables a bit, we can see that the formula is the one given on the bottom, and using that formula as well as using the simulation, one can see that the value of charge on each tape should be 2.34 into 10 raised to the power minus 9 coulomb. It's important to know that all SI units were used in all calculations. Also, if you want to look at the simulation I made, the link for it is given on the top. Now, how do you find the total number of electrons in each on each tape? You can do that by first finding the total charge, which we have already done, and then dividing that by the charge for each electron, which is 1.6 into 10 to the power minus 19 coulomb. On doing that, one can see that there's a deficiency of 1.4 into 10 to the power 10 electrons on the tape. Since we already know it was positive, therefore it's a deficiency. The tape was 20 centimeters in length and 2 centimeters in width, which essentially leads to an area of 4 into 10 to the power minus 3 meter square. Um, Assuming that the length of an atom is 10 to the minus 10 meters, one can calculate the area as 9.8 into 10 to the minus 20 meter square of what an atom covers. That leads to a total of 1.27 into 10 to the 17 atoms in the total entire area we're talking about. This is essentially means is that, what it essentially means is that more than half the total atoms were ripped off of the electrons when the tape ripping happened. Now there were some questions in the PDF that need to be answered. What happens if the electrons have a positive charge? If the electrons have a positive charge and the protons have a negative charge, then things should not change that much. The U tapes should still repel since they are made from the exactly same manner, so they'll obviously have alike charges. However, the tape will not get repelled when you bring a plastic pen near it. Will get repelled when you bring a plastic pen because they are like charges. Handling the tape too much can lead to it losing its acquired charge because a body essentially acts like a ground. It can give or take as many electrons as another body requires. Thus, touching the tape would neutralize it and lead to it losing all its charge effects and not lead to our experiment being successful. And that's it. Thank you.